So we finished up with linear equations. We're now going to move on to solving quadratic equations. In terms of solving quadratic equations, we're going to do this in four separate parts. Part one will be solving quadratic equations by factoring. Part two will be solving quadratic equations using the quadratic formula. Part three, we will look at harder quadratic equations. So these are ones that are messier than the ones we see in parts one and two. And for the fourth part, the fourth video, we'll look at worded problems. Worded problems. These are all fairly distinct and they all tend to operate in a little bit of a different way than the others. So in this video, we're going to start, this is number one, we're going to start with factoring. So let's talk about solving a quadratic by factoring. So a quadratic equation we've established is something of the form y equals ax squared plus bx plus c. And we said that if the a was equal to 1, that was called a monic quadratic. If the a was not equal to 1, it was called a non-monic quadratic. When we're solving quadratic equations, we can solve monics or non-monics. It actually doesn't matter which type we're solving. The factoring is going to work the same way. So if we have an equation of this form, what we need to do is we need to rearrange it so it's equal to the number 0. So we're going to minus y from both sides. In this case, y has to just be a number. This gives us 0 is equal to ax squared plus bx plus bracket c minus y. This is where c minus y is just some number. And then you are going to factorize. Factorize. Once you have factorized this, you will have something in the form of 0 equals, there will often be a term a, we might call this, not necessarily it's going to be a, it's going to be some parameter. So let's call it delta x plus alpha, and this is going to be multiplied by theta x plus beta. This will be the factorization. Sometimes the parameters in front of the x will be equal to 1, sometimes they won't. It just depends what the quadratic was in this step. If this was a monic, they'll be equal to 1. If it was a non-monic, they won't. Once you have factored down to this step, the way we solve is we set each of these bracketed terms equal to 0. So the first one, we get delta x plus alpha equals 0, minus alpha from both sides. We get delta x equals minus alpha, divide both sides by delta, and this tells us that the first solution, x1, is minus alpha on delta. For our second one, we set the second bracketed term equal to 0. So this is theta x plus beta equals 0. We solved minus beta from both sides. This gives us theta x is equal to minus beta. Divide both sides by theta. And we find that x2, solution 2, is minus beta on theta. So this process for the typed quadratic equations we're dealing with is going to work most of the time. Usually when you're given these equations at the beginning, they will be in the form quadratic equals 0 or quadratic equals a number. If they are not, you must rearrange them so that they are. So let's have a look at some examples. We'll look at two examples, one which is already quadratic equals 0 and one which is not. So the first one, we might take something relatively simple. We'll take 2x squared plus 3x plus 1 is equal to 0. So we need to factorize the quadratic. Well, it's a non-monic and it's a non-trivial non-monic. So we'll do this by separation method, splitting the 3x up. 2 times 1 is 2. So we're looking to split the 3 into two numbers that add to make 3, where the coefficients multiply to make 2. So two terms that add to make 3x, where the coefficients of those terms multiply to make 2. That's going to be 2 and 1. So we get 2x squared plus 2x plus 1x plus 1 equals 0. Factor the first two, factor the second two. This becomes 2x in front of x plus 1, and then 1 in front of x plus 1 all equals 0. We bring the x plus 1 out the front. We have x plus 1 times 2x plus 1. This is equal to 0. Now we set each bracket equal to 0 and solve individually. So we've got x plus 1 equals 0, minus 1 from both sides. This gives me x is equal to minus 1. This is one solution. The other solution, we let 2x plus 1 equal 0, minus 1 from both sides. This gives me 2x is minus 1. Divide both sides by 2. This gives me x equals minus 1/2. So these are our two solutions to this quadratic equation. So this was a nice one. It was the quadratic equals 0 straight away. We could have a slightly harder example where we didn't have quadratic equals 0 straight away. So we could have something like, let's take maybe b plus 10 on b is equal to 7. So this is not a quadratic equals 0, but if we fiddle around with it, we should be able to turn it into a quadratic equal to 0. So let's multiply everything by b to begin with to get rid of the denominator. Times b times b times b. It becomes b squared plus 10b equals 7. Oh, sorry, this is not 10b. The b's cancel. This b cancels this b. Equals 7b. Minus 7b from both sides. And I get b squared minus 7b plus 10 is equal to 0. This is quadratic equals 0. So now we're going to factor, set each bracket equal to 0, and solve. So we factorize this using our monic quadratic stuff. We need two numbers that add to make minus 7, multiply to make plus 10. Should be minus 2 and minus 5. So you get b minus 2 times b minus 5 equals 0. So this implies that b minus 2 is equal to 0 and that b minus 5 is equal to 0. Add 2 to both sides for this one. Add 5 to both sides for this one. We get that b is equal to 2 is one solution. And we get that b is equal to 5 is the second solution. So we rearranged this to get it into quadratic equals 0 first. We had to do a bit of algebra on it. Then once it was in that form, we just did our normal process of factoring, setting each bracket equal to 0, and then solving. All right, so I'll let you have a go at some questions. I'll write two questions down. So for question 1, I would like you to have a go at factoring. We might have a squared plus 2a minus 15 equals 0. So here the direction you are given is to solve. And for question 2, we'll make question 2 a little bit harder. We might make this, let's see, we might have bracket 5, 5a minus 3 times 3a plus 1 is equal to 1. And the instruction here is solve. So pause the video now, have a go. Okay, so now that you've paused the video, you've had a go, let's go through the solutions. The first one is quadratic equals 0 straight away. So all we need to do is factor the quadratic, set the brackets equal to 0, and solve. We are looking for two numbers that add to make plus 2, that multiply to make minus 15. So plus 5 minus 3 should work. So we get a plus 5 times a minus 3 is equal to 0. So set the first one equal to 0, we get a plus 5 equals 0. Set the second bracket equal to 0, a minus 3 equals 0. Minus 5 from both sides here, plus 3 to both sides here. We find that a equals minus 5, and we find that a equals plus 3. So these are our two solutions. For these questions, one thing you can do with them as well is you can check them. So you can check where you take the values that you've just found, you plug them into the quadratic and you check that it equals 0. So if it's minus 5, you would get minus 5 squared plus 2 times minus 5 minus 15. Well, this is 25 minus 10 minus 15. This equals 0. So minus 5 checks out. If it's 3, you get 3 squared plus 2 times 3 minus 15. 3 squared is 9. 2 times 3 is 6. minus 15. This is also 0, so this checks out. For question 2, this is a little bit harder. We need to expand the brackets, move everything to one side, and then factor again. So let's do a FOIL expansion. 5a times 3a, 15a squared. 5a times 1 is plus 5a. Minus 3 times 3a is minus 9a. Minus 3 times 1 is minus 3. This equals 1. Going to minus 1 from both sides straight away to get it equal to 0. We have 15a squared. 5a minus 9a is minus 4a. Minus 3 minus 1 is minus 4 equals 0. This we now want to factorize, set each bracket equal to 0, and solve. So it's a non-monic, it's a non-trivial non-monic, so we want to split the middle term up. So 15 times minus 4 is minus 60. So we're looking for two terms, the coefficients of which multiply to make minus 60, they add to make minus 4. So we could think of the products of minus 60. Well, minus 1 and 60, 60, so minus 1 and 60, 60 and minus 1. We've got 30 and minus 2. We've got 2 and minus 30. We've got 10 and 6, or 10 and minus 6, and then 6 and minus 10. Well, 6 and minus 10 definitely work. 6 minus 10 is minus 4. So this becomes 15a squared. We'll make it minus 10a plus 6a minus 4 equals 0. Factor the first two, factor the second two. We get 5a in front of 3a minus 2. From the second one, we can divide both of them by 2. So we will get 2 in front of 3a minus 2 is equals 0. Common bracket, so we can factor it out the front. We get 3a minus 2 times 5a plus 2. This is all equal to 0. Now we can set each bracket equal to 0, solve, and we're done. So the first one, we get 3a minus 2 equals 0. Add 2 to both sides. This tells us 3a is equal to 2. Divide both sides by 3. This tells us the one solution is 2/3. For our second solution, we set the second bracketed term equal to 0. 5a plus 2 equals 0. Minus 2 from both sides. This tells us that 5a is minus 2. Divide both sides by 5. And this tells us that a is minus 2/5. So these are our two solutions to this equation. Now, one thing that we can do is if you have a question like this, you pretty much want to check. I know it takes time, but you want to do it to make sure that it's actually right. There's a lot of stuff going on in this question. It's very easy to lose or gain a sign or a number. So let's check these. Let's copy down our original equation. We'll change our color to green to indicate that we're doing a check. Check bracket 5a minus 3 times 3a plus 1 equals 1. For a is 2/3 and a is minus 2/5. Well, if a is 2/3, we get 5 times 2/3, which is 10/3 minus 3, times 3 times 2/3, which is 2 plus 1 equals 1. 10 on 3 minus 3. Well, 3 we could write as 9 on 3. 10 on 3 minus 9 on 3 is 1/3. So we get 1/3 times 2 plus 1 is 3. This equals 1. This is true. So 2/3 definitely checks out. Now we need to check the minus 2/5. Minus 2/5. So we have 5 times minus 2/5. That's minus 2 minus 3. Multiplied by 3 times minus 2/5. That's minus 6/5 plus 1, which is 5/5 equals 1. Well, minus 2 minus 3 is minus 5. Minus 6/5 plus 5/5 is minus 1/5. Minus 5 times minus a fifth is 5/5, which is 1. So this is also true. So therefore, a equals minus 2/5 is correct as well. So when you're doing these questions, it is a little cumbersome to check. You do want to get in a habit of doing it. If you are in an exam and you have a question like this, could be worth quite a few marks. If you mess it up, you've lost the marks, even if you knew how to do it. If the question requires you to use your working to then do another part and you mess up the first part, you're going to lose a lot of marks. So checking, even though it might take a little bit of time, it is worth doing.